Now let's talk about an important theorem known as principle of mathematical induction. Okay, let us see what this is. Principle of mathematical induction. So this principle states that let P of n, okay, be a statement okay where n is an natural number. Okay, now if Pn is true, if P of n is true for n is equal to n0, okay, or any initial value of n, okay, and assuming pk is also true, okay, k is any other value for n, okay, assuming pk is true where k is greater than equal to n0, okay, then if pk plus 1 is also true, then we can say that Pn is true for all natural numbers. Okay, then we can say that P of n is true for all n greater than equal to n0. Okay, so this is your principle of mathematical induction. What you have to do over here is you have to check if Pn is true for an initial value of n, okay, then you have to assume that P of k is true and you have to somehow prove that P of k plus 1 is also true. If you can do that, then you can prove that P of n is true for all natural numbers greater than equal to n0, okay, where n0 is the first step variable that you have taken. Okay, now in the principle of mathematical induction, your step 1 is known as basis of induction. Okay, and your step 2 is known as induction step. Okay, and your assumption, this assumption that P of k is true is known as induction hypothesis. Okay, the assumption P of k is true is known as your induction hypothesis. We are now going to take some examples and we are going to see how this principle of induction helps us to prove some results. Let us take an example so that we understand this principle better. Okay, let us assume that you've been asked to prove this particular statement. The statement is prove that 1 upon 1.4 plus 1 upon 4.7 plus 1 upon 7.10 so on up till 1 upon 3n minus 2 dot 3n plus 1, okay, is equal to n upon 3n plus 1. So you have to prove this statement. Okay, so we are going to just assume that this is our Pn, okay,